It's rolling. Here we go.
It's rolling. Oh, it's blurry.
Am I in focus?
It's blurry.
Just tap me.
Okay, yep. Okay, nice.
Okay, thank you.
You've been tapped.
Oh, but Mr. Sand, you can't go like.
I know. Like right to here?
Yeah.
That's how far I'm going to go.
Yeah.
Okay, so the final thing we'll talk about is a mission. A mission. Okay. Now, let's start off. The guys who had to go to basketball.
Yeah, I have a question.
Which one of these you want to start off?
Oh, really, Mark?
No, I wanted to go over what we did today.
That's a mission.
That's a mission.
Yeah, so a mission.
Want to talk about that? Ben, what do you want to talk about real quick?
Our mission works.
Okay, fine. Let's talk about that. Then, all the other stuff you can see online, right? Okay. So, a mission. What we talked about today. I'm going to go through this kind of fast. Like a lecture style, right?
Yeah.
This is what we talked about today. Today we said that, what did we say today? We said that here's an atom, you can excite it with some energy, right? And then, if you take another picture of it, it'll give off that energy. Except this energy now is not the same kind that was put in. Now, it's, where's the red? I just had red. Here it is. Now, it's light. Okay, now it's energy, but it's light energy.
I have a question, Sam.
Okay? What's on?
Yeah, I have a question.
What kind of question would you ask in the paper that you gave about that?
Great. So the question I would ask is something like this. I'd ask you something like, I don't know. If you have, I'm going to say, if a wavelength of, let's say this, if a wavelength of light is emitted from an atom, at, let's say, 352 nanometers, how much energy is emitted? We have not gone over these questions explicitly in class. Okay, I gave you the formula today. How much energy is emitted? Is that okay? Or do you guys want me to go back over this?
Well, I have a question about that.
About this?
Yeah. When the energy goes into the atom, does it come out being light energy?
Yes.
How's that work? Like it goes through the atom and then...
It goes into the atom. The atom right here has, we haven't done it yet, but we draw in these little rings. Those little rings are orbits, right? In the orbits you have an electron. The electron absorbs that energy. It goes up an orbit, right? Then it's excited. It's all excited because it's been absorbing energy. Then it releases that energy in the form of light.
Okay.
Okay? Depending on how far it drops, you'll get different wavelengths of light. Big drops will get you more energy, and so it'll be shorter wavelength. Smaller drops will get you, you'll have to just replay that over and over again. Smaller drops will get you less energy, so it'll be a longer wavelength. The longer wavelengths have the lower energy. The longer wavelengths have the lower energy. So, for instance, red versus, we don't have purple up here, but blue.
The longer wavelengths have the lower energy, the shorter wavelengths have the highest energy.
That's right. So let's say this electron on here, let's just take this electron, we're just saying hypothetically, this electron over here gets really excited. Wow! It's so excited! And then it drops down, it goes down to the first ring. Okay? When it does that really high jump, what kind of light is going to give off? Is it going to be a really short wavelength or is it going to be a really long wavelength?
Long.
Now you want to say long because that makes sense, it's a long jump.
Oh.
But the wavelength of light that's given off is short because it's a lot of energy given off.
And how do we know when it's going to be, okay, this might be a really stupid question, but how do we know when it's going to be short, when it's going to be long?
How do you know it's going to be short or long? Well, you can look at this little diagram right here. Right? If it jumps from here to here, compared to here to here. Okay, which one is long, which one's short?
Well,
Obviously,
yeah.
right? I will make it obvious for you if I ever ask a question like that.
Alright,
Wait, I have a question.
we're good.
Yeah.
Wait, you said the long one has less energy and the shorter one has more energy? The shorter
Yes.
Mm-hmm.
So, wait, so, and if, when the energy goes in electrons, does it go out? That's more towards the nucleus.
Does the energy go out or does it go towards the nucleus?
No, you know the bouncing thing?
The electron.
Oh, yeah.
You gotta be specific
Yeah,
here.
so
The electron. When it gives off energy, it comes
The
back towards
bouncing
the
thing.
nucleus. Right. Okay, so when it gets excited, it gets pushed away.
And that's
It's all
where
excited, and then it drops down when it gives off that energy. And so at first it absorbs the energy, goes up to a higher state, and then it relaxes and it emits that energy.
so why does it go like go out again? Like go long?
Why does it go out? Because energy is absorbing energy. So this electron right here, when it absorbs that energy, it gets excited, it gets pushed away from the nucleus.
And that will be electron, right?
The electron is pushed away from the nucleus.
So what's the other one? Like the little one. Okay.
This is still, I'm just giving you an example. Let's say that this is still an electron. I just said, what if we got a drop from, let's say that's the nucleus. We've got a drop from here to here. It drops from there to there. It's a small drop, right? So it's going to be a long wavelength, so probably like red.
Right.
Okay. Good. Yeah.
Okay, so then when there's no more energy left, that's when it starts to relax and go back to where it was? When the energy is stopped? Or
Think about it in terms of like filling up and letting out of energy. All you need to think about is that this electron is absorbing energy, okay? It's excited, and then it'll spontaneously emit all that energy that just absorbed.
So it'll
Yeah,
light
Or
up.
maybe it'll emit part of it and drop down just a small level. Okay? So when it is then released all the energy it absorbed, it'll go back to its original level.
oh yeah,
That's
there's
what I don't know.
okay, well
Is
okay.
that what you meant?
Yeah.
Okay. Yes.
For going to the formula, briefly went over. So you're always going to have to find the energy or the wavelength would be the unit.
Good question. Excellent question. So that brings us to this question right here, the thing that we're going to talk about tomorrow in class. Okay? This is a question I could ask about this. So if a wavelength of light emitted from an atom is, wow, I was thinking about something else when I wrote this, is 352 nanometers. Whoa, how much energy is emitted? Wow, this is a lot of numbers in actually just one. So imagine this wavelength of light is 352 nanometers. You might just know already that that's kind of purplish color.
Yeah, it's
But if not, it's not.
What?
I won't test you on that.
It's not
Okay?
sort of the
Don't
rainbow
worry.
colors again? Rapunzel?
Anyway, the point is we've got this little equation.
Rainbow okay,
Here's the equation. Will this be given to us? Yes, it'll be given to you. Do we need to know this? No.
So the constant.
These are constants. They will be given to you. Look on your other side of the periodic table. That's your formula sheet. Look what's given to you.
Can we bring this?
You can't bring that, but that'll be given to you on the test again. So you can just say, oh, I know exactly what's going to be on it. Okay? So this, H, this is Planck's constant. That just stands for this number right here, times 10 to the 34th. We're not going to worry about the units for this because if they just get kind of ugly, kind of fast.
We never learned how to solve, right?
We're going to learn tomorrow, Mark, too.
I'll do it right now.
What is this?
This is 3.0 times 10 to the 8.
Why then?
Put the 0 there.
The
and
one
just
thing
put
that they don't give you, and like I think you have to find the lambda or something like that.
Well, right now we've got, it says the wavelength of light emitted is 352. So in this equation,
That is 352.
this is 352. That's right.
Why?
That's 352 nanometers. But oh my gosh, this equation, this is going to be the thing that trips you up. This equation, that wavelength is not in terms of nanometers. It's in terms of
Nanometer.
meters, just plain meters.
Oh.
So you're going to have to make a small conversion. This is the
No,
conversion.
so bad.
Okay, and then we'll find E once we do that. So, since we have to give this in terms of meters, we have to change 352 nanometers into meters. Can we do that?
Yeah.
Wait, why do we have to change it to meters?
Because it's nanometer. It's
That's the
not.
only acceptable
negative.
unit for
For
weight.
this formula to work, okay,
It's negative
we're going to
nine.
have to turn that 352 into meters.
Yeah, why?
So we'll do.
For the formula to work. I just said it in the first
needs
part of the
to be.
sentence.
Wait, Mr. Sun, are we gonna learn this in class tomorrow?
Yeah.
Okay.
King Henry drink delicious chocolate
I
milk.
thought people already knew this. And I was like,
George.
Drink my delicious
Isn't
chocolate
it
milk.
negative
And then-
9?
And then we've got, what else below this? Micro and nano.
Yeah, so it's negative 9.
So this is -9, then we've got -8, -7
Oh,
is
negative 6.
micro. Whoops,
Where's the positive 6?
hold on a second. I made a mistake. This is, micro is -6, milli is -3,
Yeah, I was
2,
right.
-1, deci, and then meters is 0. So we need to move back 9 places, right? 9 places. You're just loving it, aren't you, Ben?
I have a question though.
I'm sure you do. Here we go.
You know I do.
So let's go back 9 places. Can you guys do that for me? How do you go back 9
Oh
places?
man.
Well, let's think about this.
Oh my
It's a
God.
point, and then there's
To the left.
6 zeros in front.
5, 6, 7, 8, 9.
There's 6 zeros, so point 00000. Blah 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 blah.
No.
Yeah.
So we've got 6 zeros in front, and this is how many meters it is. That's right.
So the entire.
So this now, all you have to do is change this. This is really a conversion problem. Conversion and plug it in. So convert this to meters and then plug it in, and you've got the answer.
okay.
Wait,
I think the answer. I think the answer now.
You need to solve.
Mark, all you do is you multiply the top, what he gave you at the top, and what he gave you at the bottom, and then you divide it by point all that thing over there, and then you get E. There's
So
literally
this number
no
times this
algebra
number
involved.
divided by
Oh,
this number.
okay.
What
That's
do
the
it?
answer.
What do H and C stand for?
This is Planck's constant.
We have to know that.
That's what H stands for.
Yeah.
Do you
Okay.
have to know that?
And then.
What we given?
Okay.
Try not to get upset because I know I said that at least 3 times.
Yeah.
2
So
times of
you're
those.
supposed to move over 7 times.
They will be given to you. I said turn over your sheet. That's what's going to be given to you.
No, I'm saying you know the names.
The names, that's totally different. No, you don't have to know the names. It's just H and C.
So did you move to the decimal how many times?
This
It's
time,
6.
I moved it 9 times from the very end of this. So this is
Why 9?
nanometer. Because there are 10 times -9 nanometers for every meter. Wait, I said that wrong. For every meter there's, say it right. Every nanometer is 10 times -9 meters. Okay, so that means you have to move this decimal place back 9 times. Right? So it's a really, really, really small meter,
Yeah, I kind of tried.
right? So on your little, yeah. So we,
Got 8.
but it should be back 9 times.
Would that be the final answer?
What's critical?
You make 9 jumps back.
Are we
Let's see
good?
if you did it. Let me try right here. 6.626 E to the -34. Enter.
Wait, where do we start from on King Henry?
It's the created nuclear reaction.
Oh my God.
The chain reaction.
Mr. San, so you're going to be giving us
Chain reaction.
H and C?
Yeah. It's
Yep.
It's the least amount of stuff. that
Where
has to-
where are we starting from
4 times 6.
on the King Henry thing?
You start from the middle, meters. From the base
I
unit.
got this.
I thought we were trying to get meters.
Yeah.
So where do you start from?
You start from
No, I didn't.
the what's given to you, nanometers.
This is the formula.
Where's nanometer? Oh,
You
okay.
have to, it's down.
Oh, I'm sorry.
Small.
Okay. Can you
The
just
flag's
like,
negative.
You're going up.
When you're moving the decimal place, yeah, you're going up.
my
On
delicious
King Henry, you're
chocolate
going up.
milk.
Is what I'm at.
Okay, then we've got skip
From
2,
where? From
and then
nanometer?
micro,
Yeah.
skip 2,
Yeah.
and then nano.
Yeah.
Alright?
Oh, that's what it is.
Yeah, because we're down to nano.
Let's skip